This video goes over the solution for problem 23 on page 282, chapter 7, linear programming models. In this particular problem, it deals with minimum cost or minimization of cost. So the optimal solution function is, okay, I want to minimize my costs. Therefore, if I'm considering two resources in the production of my product, what combination, what's the output, or in this case from the standpoint, I guess we should refer to it as what's the input of these resources whereby my costs will be minimized. This particular problem is pretty well straightforward. All what you have to do, of course, is you were given the objective function, $1 for X and $2 for Y, and you were given the constraints. You were given 1, 2, 3, 4 constraints, and once again on the bottom there where it says X, comma Y is greater than or equal to 0, that's just making reference to the integers are all positive. We cannot have negative integers when we're dealing with linear programming. So let's just go ahead and let me take you through the mechanics. Once again, QM for Windows. I'm using the PC platform or the PC environment. One of the problems we have, I don't know if it's a problem or not, but if you're in a Mac platform, the iOS, it is quite cumbersome in regard to linear programming. Now, in our previous work dealing with forecasting, etc., it didn't make any difference if we were in a PC environment or a Mac environment. It was pretty straightforward and easy. Both platforms utilize the software readily. However, when it comes to linear programming, it's not so cumbersome, and that's why I did send out an email and just saying, don't worry about the graph for Mac users, just give me the optimal solution to the problems at hand. So once again, I'm in a PC environment. I'm already in a QM for Windows, so basically what we would do is drop down what's the modular we want. Well, we want linear programming, and as we can see, linear programming file, it's a new one, and once again up pops our menu and is asking us for the number of constraints. Well, in this case we have 3 constraints. Excuse me, we have 4 constraints, and the number of variables is 2, and you can see they're asking us what's your objective function. Well, it's minimization this time, and we'll just go ahead, hit OK. X1, X2, it's looking at the objective function as indicated in the problem. It is 1. We do not put dollar signs in. And then for X2 or Y, it would be 2. So I guess I should probably come up here and just change that over to X, and I'll change this over to Y. As we did under profit maximization, in this case, in other words, what we're saying, the cost of X is 1 per unit and the cost for Y is $2 per unit. And then the first constraint, constraint 1, what we want to do, we want to change the 0 to 1, and we want to change the 0 to 3. As you can see, when we're dealing with minimization, our sign changes to greater than. When it was under profit maximization, the sign was changed to less than. And if we would have to go in, which we'll do that in the 4th constraint, I'll show you at that time. So in other words, what we're saying, constraint 1 is 1x plus 3y is greater than 90. For constraint 2, it would be 8x. 2y has to be greater than 160. Constraint 3 happens to be 3x, and we'll say 2y, or 2 units of y, and 120. That's what we need. And for the fourth one, it says y has to be 1y has to be less than or equal to 70. So we can't have a 0 there, so just put a 1 in there. So that's really 1y. And this is less than or equal, well, again, we can go on here, drop down, less than or equal to 70. And then we come back and we simply say, solve it please. And in our solve, our optimal output solution for minimization of costs would be 25.71x, 21.42y, and our cost would be $68.57. If we want to see a graph, well, as I said, we don't really need to see the graph. Excuse me. If you want to see a graph, you can always use the graph mechanism. But however, for Mac users, it's very cumbersome to bring up the graph. But from our perspective, our point of view, what we really are interested in is really what is the optimal output solution, or in this case, the optimal input solution, whereby we will minimize our costs. And that is, once again, 25.71 units, 21.43 units, and the costs that we're going to have to write that check for is $68.57.